Now, before I talk about monitoring a reaction by pressure, you want to talk a little bit about dealing with reactions that are not just A goes to B. Like if we have what I'm going to call a less simple reaction, where you have more than one reactant, like we'll just say A plus B goes to C. In the reaction that we were looking at here, where we have two reactants with each other, if you have more than one reactant, there is a possibility that the rate might depend on the concentration of both of them combined together, like interacting with each other. And that can make it really difficult to calculate the value of K. So if you have a situation where you have two or more reactants, one of the tricks that we use in kinetics is to make to adjust the concentrations of the reactants so that it makes it seem like there is actually only one of them present. Or not that there's only one, but only one of them is changing. And the way that we do that is by putting the extra reactants in extreme excess. So let's say for this A goes to B, or A plus B goes to C reaction, we wanted to study the rate of A. And what we would do is take this extra reactant B, and we would just flood the system with tons and tons and tons of B. So let's say, for example, let's put some numbers on this. Let's say that we started the reaction with 50 moles of A, and we started the reaction with something like 500,000 moles of B. And you guys know from stoichiometry, these are our I for initial conditions change, that A is clearly the limiting reactant here, and all of A is going to react, and we're going to end up with no A left in the end. And B is also going to react, but because of stoichiometry, only 50 moles of B are going to be able to react. Which means that when this reaction is done, we're going to have 499,950 moles of B, and essentially it hasn't even really changed at all. So it makes it look like the concentration of B is a constant, and it is unchanging, and it makes it much easier for us to study the kinetics. So even though it's not a simple reaction, it still behaves like a simple reaction, where it makes it look like we only have two reactant, or a reactant and a product, two things that are under study, and B is concentration is just hanging out up here at the top like it's some sort of constant.